All right, we'll talk here about the repeated measures ANOVA. Why not, right? Okay, the repeated measures ANOVA. This is different from the one-way ANOVA. It's different from the two-way ANOVA and the other types. It's its own beast, if you will. What is important to know about a repeated measures ANOVA is that it is looking at mean scores from a group that are similar to each other from a group to see if they are similar to each other or different from each other. So let me say that again, because that was a little clunky. We're looking at average scores from one group to see if those average scores are similar to each other or different from each other. The means come from continuous data, not from categories. So these are things where you're getting average scores, and those average scores are coming from the same group. So we are no longer looking at group A versus group B to see if they are different. We are looking at one group of people, and we've got data from them at multiple time points or multiple measurements, and we want to look to see if those multiple measurements or time points are the same or different. Example, you have a cohort of students, one group of students, all the same students, and those students have a GPA in their first year, in their second year, in their third year, right? Those same students have a GPA that's changing over time. The repeated measures ANOVA would show you whether the differences in GPA over time is just normal variation, right? Because not every year is going to be exactly the same. Or if at least two of the years or if all of the years are different from each other, they significantly differ from each other. And when we say that, we mean that the p-value is less than 0.05. So this is very similar to a dependent samples t-test, but the ANOVA can do more than two means. It can do two, like a pre and a post, or it can do 3 years, or it can do even more than that. When you have a significant repeated measures ANOVA, where you're comparing more than two means, so the example I gave on the last slide, years 1, 2, and 3, you will have to do a follow-up test. We call it the post hoc test. And the reason for that is because if you had just 2 years, year 1 and year 2, and the ANOVA is significant, you know that year 1 is different from year 2. But if you do this with 3 years and you get a significant test, you don't know, is year 1 different from year 2 and year 2 is different from 3? Well, is year 1 different from 3? I don't know, right? What's the breakdown? And so the way you would do that is through post hoc tests where we pair them up. We do all the comparisons of 2 at a time. In this case, it would end up being 3 tests, and now we transition back to our t-test, in this case, a dependent samples t-test, because it's the same data from the same people. And we would take first year GPA compared to second year GPA, first year GPA compared to third year GPA, and then second year GPA compared to third year GPA. So we would have 3 separate dependent samples t-tests, and this would allow us to see what specific groups differ from what group. This is the case if you have a significant repeated measures ANOVA. This is like a follow-up, a next step that you need to do. You will also be given the opportunity to look at interactions in repeated measures ANOVA if you add into your analysis a between groups variable. So we might have this cohort with GPA, their first year, second year, and third year, and we want to look in that within factor, we call it the repeated variable, if GPA is changing. But maybe we want to add also to our analysis the between subjects factor of first gen versus non-first gen. And maybe we want to see if the pattern of GPA over time is the same for our first gen students as it is for our non-first gen students, right? So this would add a piece to it. So we would get, as shown at the bottom of the slide here, number 1, what we call a main effect. Does GPA change over time, regardless of what group they're in, just overall for all of the students? And then number 2, when breaking it down, is there an interaction where GPA changes differently for one group compared to another group? All right, so I want you to take a look at the other video I have on how to actually run this analysis in JASP, where I will give you concrete examples of this and you'll be able to see it. Before you do that, 2 more quick things. More than 2. I lied, more than 2. First, just a quick note about the name of what the ANOVA is. As I've noted in the other ANOVA videos, it's always written in all caps. and it stands for analysis of variance, right? And so what the heck does that mean? Well, it's math that's happening behind the scenes. When we have two mean scores, like in a t-test, we can say this minus that, this average minus that average gives us this difference. But when we have more than 3 averages, the math gets a little complicated. Like, what do we subtract from what? And does it really show us the distance between the means? No, it doesn't. If you sit down and play with that, you'll see it doesn't actually work with the same logic. So what we end up doing are some analyses of variance, right? So instead of looking at the means, we look at the kind of spread around the means and look to see whether or not the spread around the means can help us decipher whether things are kind of close or whether they're really spread apart, right? Meaning things kind of go together and they're not significantly different, or things are kind of spread apart and they are significantly different. I will not go into the detailed mathematics behind that, but I will tell you briefly that what happens is we calculate between variance and within variance, right? Just like we do for other ANOVAs. Between variance means when we're looking at the average for the first year, second year, and third year GPAs, how spread out are they? And then within first year, how spread out are those averages? And if we look at that spread and we see that the average score for the second year falls within that spread, maybe these things aren't so different after all, right? So that's the kind of logic that's behind it, but there's a lot of detailed mathematics with some different variance scores that then get turned into that F statistic that you'll see in JASP in your output, telling you what p-value is associated with it, right? We need the variance ratio between compared to within, right? Is this one bigger and this one smaller? Then we do that division and it turns into a number, which we call our F statistic, and then that F statistic corresponds to a p-value, and then that p-value tells us whether it's significant. There's a lot of steps in there. You can consult your textbooks or other sources to kind of read more in depth about that, or to see examples if that's what you're interested in. Or you can just say, all right, I kind of got a feel for it. Let me move on and look at the concrete analysis examples in the next video. Whatever works for you. When you do this, you can use a computer. You should use JASP because I say so. That's fabulous. It's an excellent free statistical software tool that you can download. And please also remember to take some time to look at things beyond the p-value. I know we're talking about p-value here because the reality is the field is still using p-values to determine statistical significance. But as Jeff Cummings shows in his Dance of the P-Value video, there are a lot of limitations to p-values. They are not necessarily everything they're cracked up to be. And effect size is one of the ways that you can really enrich your analysis and get some information that might be more meaningful. What is effect size and how do we wrap our heads around that idea? You can check out my video on what does D equal 0.08 mean? A question I get quite often. Go and take a look at that, and it can help you think about effect size and what effect size can do to help you with your analyses. That's repeated measures ANOVA. It's probably the fastest video I've ever made on repeated measures ANOVA, but it'll give you the background. Go check out the analysis video and have a lot of fun with it.